Hi class, let's talk about the creation and formation and different parts of lightning bolt. Okay, and so lightning all begins with a separation of charges within the cloud. So positive charges collect near the top of the cloud, negative charges near the base of the cloud, and positive charges near the surface. Okay? One way that I remember this is that the positive charges look like the letter T. Negative charges start with N, and positive charges near the surface look like the letter T. And so that's TNT, which is boom, which is the sound of thunder that lightning generates. Okay? So hopefully that's a little good way for you to remember how the charges are separated within the cloud. All right. Now, how do the charges get separated? It's not real well understood, but scientists think that there are ice particles in the middle of the cloud, and then when updrafts carry ice crystals, little tiny snowflakes past these ice particles, that they rub together, and in doing so, it's going to remove electrons from the ice crystal. And so positive charges accumulate at the top of the cloud, negative at the base of the cloud, and positive charges at the Earth's surface. Okay, so how does lightning then get started? Well, let's first look, and I forgot to mention this, that now we've got a separation of charges. We have an inequilibrium in the atmosphere. And as I've mentioned all semester long, whenever there's an inequilibrium, the atmosphere is going to try to reestablish equilibrium. In this particular case, when there's an inequilibrium in terms of the charges within the atmosphere, a lightning bolt is going to be created to reestablish equilibrium. All right, so how does it do that? Okay, another thing that I probably need to tell you beforehand, we're going to be looking at cloud to ground lightning, okay, because that's most relevant to us. It's the most dangerous form of lightning to us, but that's only about 10% of all lightning bolts are cloud to ground. About 90% of lightning actually takes place within the cloud, okay? So even though that we're looking at cloud to ground lightning, it's relatively rare. It's certainly in the vast minority of all lightning that occurs. It is the most important to us because it's the most dangerous. All right, so we've got this collection of negatively charged particles, electrons, near the base of the cloud. Okay, and those negatively charged particles are going to start to surge towards the surface. So we get a surge of electrons leaving the base of the cloud. Okay, and I'll draw that as just this little dot here, dot or dashed line. Okay, and this is the first part of a lightning bolt. This is called a leader. Okay, and a leader is a narrow channel of negatively charged ions. Okay, and so oftentimes you'll see this, a lightning bolt is a single streak through the sky, and that would be a leader. And other times you'll see lightning will branch off, okay? And we call this a branched or stepped leader. And it's no different than a leader, it's just that it's branched off or create a stepped effect. Okay, it's still negatively charged ions leaving out of the cloud. Again, this is not a lightning bolt yet. This is simply a surge of electrons coming down out of the cloud. It's the start of a lightning bolt, but it's not a lightning bolt yet. Okay, and so these negatively charged ions are making their way towards the Earth's surface, where you have positive charges. Okay, as the negatively charged particles make their way down towards the surface, just like a magnet, opposites attract. The negative charges are going to pull the positive charges from the surface up towards them. Okay, so you get these little pulls of positive charges from the Earth's surface up towards these negatively charged leaders or stepped leaders. Okay, these positive charges that are pulled up are called streamers. That's the second part of our lightning bolt. Okay, and streamers are positive charges that are pulled upward. Okay, as the negative charges from the leaders approach the surface. Okay. Now this is very similar to a little game I used to play when I was a kid. Maybe you did too. You take some magnets and you put a magnet on the table and you hold one in your hand and you see how close you can get the magnets before the magnet on the table jumps up and attaches itself to the magnet in your hand. Okay? That's very similar to what's going on here. The leader, the negatively charged particles, are like the magnet that you hold in your hand. The streamers are like the magnet that you put on the tabletop. And you take the one magnet in your hand, the leader, bring it down towards the surface, and you see how close it can get until the magnet on top of the table, which would be similar to the streamer, jumps up and connects with the magnet. Okay, so these streamers then leaving the Earth's surface and trying to connect with the negative charges of the leader that's coming down. This is why you don't want to be the tallest object in an area. So you don't want to be a golfer out on a golf course because the club might be higher up and streamers might be leaving the golf club. You don't want to be out fishing because your fishing pole will be higher than the objects around the environment. A streamer might be leaving the fishing pole. And so you certainly do not want to be the tallest object in your environment. Okay? Now, eventually, one of these leaders is going to connect with one of the streamers. And let's say that it's this one hitting the tree. Okay? When the negatively charged leader makes a connection with the positively charged streamer, you get what's called a return stroke. So this is the third portion of our lightning. It's called the return stroke. And the return stroke occurs when the negatively charged, I'm having trouble today, negatively charged leader or stepped leader connects with the positively charged streamer. Okay? When you get that connection of the leader and the streamer, this initiates the lightning bolt. Okay? So this connection between the negatively charged leader and the positively charged streamer, this creates the initial flash of the lightning bolt. Okay? And so some people will ask, is it cloud to ground lightning or ground to cloud lightning? Okay? And the answer is yes. The flash actually occurs from ground to cloud. The flash occurs from cloud to ground. Our eyes are too slow to see it, but that's actually, the flash actually goes upward. Okay? The electrons are going to flow downward. The electrons flow from the cloud to the ground. The electrons flow from the cloud to the ground. So is it cloud to ground or ground to cloud? Yeah, it all depends what you're talking about, okay? So when you get the return stroke, when the negatively charged leader connects with the positively charged streamer, you start to drain electrons from the leader first, okay? So this comes up and then back down, this comes up and then back down, this drains here, and you get your initial flash of lightning, okay? So that's the return stroke. The return stroke is when the negatively charged leader connects with the positively charged streamer and you start to drain the electrons from the leader. The last part, the fourth part of our lightning bolt is what's called a dart leader. Okay. And these are you are very familiar with. Okay, so a dart leader, what a dart leader does is it drains negative charges, the negative ions from the cloud. Okay, and why I said you're familiar with this is because this is what causes the flickering. So whenever you see a lightning bolt, if you see flickering taking place, that's because of the dart leaders. Okay? And so you create the initial flash with the return stroke, but then the negatively charged particles, the ions within this cloud, okay, will drain down the same path. And so that's going to create so you get the initial flicker, you get the initial lightning bolt from the return stroke, and then you get a flicker every time negatively charged ions are drained from within the cloud. And typically you get 2 to 4 flickers, 2 to 4 dart leaders per lightning bolt. Okay? All right, so that's lightning. I think it's one of the more interesting parts of meteorology. I love to watch a good thunderstorm with lightning as long as I'm in a safe place. So, all right. So that's it for lightning class, and I'll talk to you later.